Okay, so another thing that we were really interested in was mud. This is recreation of the limnology lab at Iowa State University. Not really. I mean, it's just what people do with mud. But we're really interested in how fast mud builds up because it has an effect on the kind of habitat there is. Yeah, this one, I see you're looking at this one. This one over here is they light the mud in some places. This is a little flame. You might try it. I don't know. In Finland, they do this in the wintertime. They light bogs, but they have nothing else to do but drink vodka over there. So no, the cast no aspersions to many Finnish friends, but they've assured me that that's true. Lighting bogs and drinking vodka. Anyway, never mind. Okay, so lots of reason to be interested in mud, and there's a lot of mud moving around in this watershed, and so we looked back in the historical records that we could find and did some measurements of how much mud is deposited out there. Just wanted to show you this picture. It's too small of a number. The numbers are too small for you to see really there. But this is what Black Hawk Lake, we've got a morphometric map there showing you what Black Hawk Lake looked like probably after it was formed. I don't know if I ever told you this before, but this kind of lake is formed by a big chunk of ice from the glacier breaking off, getting buried in gravel and sand and the moraines, and then the ice melts away and leaves a nice big depression. Most of our natural lakes in the state of Iowa are made that way. So you can kind of see the ice blocks, big ice block there. That's the deepest part, was right here, sort of in the middle. And we got this from some coring data from the early 1900s where they ran cores down there. And then by 1916, in the color, of course the deepness of the blue indicates the depth, and by 1916 it was a whole lot shallower than that. Okay, so it was pretty shallow by 1916 with a lot of sediment coming in from a fairly good sized watershed. These are sediment deposition rates since over sort of the geological history of the lake, and these are essentially in yards again, so you can see they go up to some pretty big numbers. A fair bit of sediment came in over about 8,000, from 8,000 BC to about 1916. Okay, so lots of sediment built up, and it always focuses down into the biggest holes and fills them in first. Some places in the lake actually got deeper. So the green part, red part means the sediment got thicker. The green part means that the sediment got thinner. So some places, due to erosion and wind erosion and stuff like that, they will change in sort of the form of lake bottom. And then between 1916 and 1935, you can see a lot of green on here. And this is from some repeated morphometry measurements that were made in that period. And it looks as if there was well, in fact, we're pretty sure there's a big sediment compaction during that period because the lake was getting really, really dry during the Dust Bowl era. Okay, so this is just a map down here showing the intensity of drought in the United States in 1934. So we're guessing that there was some sediment compaction, it looks like, and it was a fairly large amount of compaction over that amount of time. Then between 1935 and 1973, things really got interesting because there was a lot of dredging that went on. And there was some filling here, and that was kind of on purpose, filling there, and some dredging out below, actually below the original bottom over here in Town Bay and so on. So not much change over here, with a little bit of deposition there, but you can kind of see how that lake was changing over time. There was quite a lot of dredging going on at that time. And then sediment deposition between 73 and 2006. These are repeated surveys. You can see some places where there was quite a bit of removal, giving the kind of dog-leg bathymetry that we have today. And here we've got some filling over time in various areas in the lake. Okay, so I just really like lake mud. It's really interesting because it tells us how habitat changes. So, how has the lake changed over time? It stayed about the same size for 10,000 years, which is pretty rare. Usually they do change in size. It was once a lot deeper in the middle than it is today, but overall the depth has about doubled since 1916. There's been enough removal of sediment and sediment compaction. The overall depth, when you look at the surveys, has doubled already, so it's about twice as deep as it was, maybe not quite. Changes have been due to intensive dredging in the lake and drought compaction. So lots of changes. And in fact, when we gave a little talk for the technical advisory team, we started out by saying Black Hawk Lake, she's had a lot of work done. You know, kind of a reference to plastic surgery and stuff. But anyway, but she hasn't had a lot of work done over the years. Okay, I don't want you to read this table. It's a lot of calculations, and you can later if you like. One of the things we found, though, in looking at these surveys and doing some what's called mass balance, you get some sense about how much sediment is being added all the time. If you see what the change in sediment on the bottom has been, and you know about how much has been removed, because we know that from some of the dredging surveys, you can make some good calculations as to what the average annual input from the watershed has been. And that's as a net, not just in, but that's in minus out. And it runs about 17,000 cubic meters. That should be 17,000 cubic meters, which is something like 21,000 cubic yards of sediment gets added to Black Hawk every year over this time period. Okay, so while we're digging it out with the left hand, we're shoveling it in with the right hand from the watershed, and that's an amount of sediment that costs us on average something like $80,000 to $100,000 for each year's worth of deposition to take back out again. So it's quite a lot of sediment coming in. It's quite a lot of lost value.